toe. Have you ever looked up at the night sky and wondered how we send things all the way up there? How does a giant metal tube defy gravity and soar into the cosmos? It's one of humanity's greatest achievements, a symphony of engineering that literally leaves Earth. Let's break down how a space rocket actually works. It all starts with a controlled explosion. Seriously, at the heart of a rocket are its engines, powerful beasts that burn massive amounts of fuel. This isn't your car's gasoline. We're talking about super-cold liquid propellants, like liquid hydrogen and liquid oxygen. When these mix and ignite, they create a colossal blast of hot gas. According to Newton's third law, for every action, there's an equal and opposite reaction. The gas shoots downward with incredible force, pushing the rocket upward. It's like letting go of an inflated balloon. The air rushes out one way, and the balloon flies the other. But a single rocket isn't enough to reach space. That's where staging comes in. A rocket is actually several rockets stacked on top of each other, called stages. The first stage is the biggest and most powerful. It does the heavy lifting, pushing the entire vehicle through the thickest part of Earth's atmosphere. Once its fuel is spent, it's just dead weight. So, it detaches and falls away, making the remaining rocket lighter and more efficient. Then, the second stage engine ignites, pushing it higher and faster. This process can repeat multiple times, with each stage giving the rocket another powerful kick toward its destination. Now, a rocket can't just fly straight up. It needs to get into orbit, which means it has to go sideways really fast, about 17,500 miles per hour, to be precise. This is where navigation comes in. Onboard computers, gyroscopes, and star trackers constantly calculate the rocket's position and trajectory. They control small thrusters and gimbaled engines that can pivot to steer the rocket on its precise path. It's an incredibly complex cosmic dance, calculated down to the millisecond, ensuring the rocket ends up exactly where it needs to be. Once in orbit, the rocket's job is often to release its payload, which is usually a satellite. A spring-loaded mechanism gently pushes the satellite away from the final rocket stage, sending it on its own journey around the Earth. These satellites are our eyes and ears in space, helping us communicate, navigate with GPS, and understand our planet better. But what about the parts we want back? Missions with astronauts or reusable boosters face another huge challenge. Re-entry. Coming back to Earth is like hitting a brick wall made of air. The vehicle is traveling at immense speeds, and the friction with the atmosphere generates incredible heat, reaching thousands of degrees. This is why capsules have heat shields, a special layer of material designed to burn away and carry the heat with it, protecting the crew or hardware inside. For reusable boosters like those from SpaceX, it's a different game. They use their engines and grid fins to steer themselves back through the atmosphere for a pinpoint landing. Ready to fly again. From a fiery launch to a delicate orbital ballet and a scorching return, every part of a rocket's journey is a marvel of human ingenuity. It's the engineering that leaves Earth, allowing us to explore the unknown and connect our world in ways we once only dreamed of. Thanks for watching. If you enjoyed this journey into space, don't forget to like and subscribe for more deep dives into the amazing world of science and technology.